Hi, good day, sir. My name is Karthikeya Analaki Ponnalagu. My matrix number is 25106358 So today I'm going to present my assignment 1 for Datacom, which is IoT Pharmaceutical Network Design and Configuration. So basically, it's easier way to say it's basically smart pharmaceutical factory. So for this pharmaceutical, I named it as KK Pharmaceutical, where this is not a normal factory. It actually is a fully automated with cyber physical system where every door fan sensor is a part of secure and segmented network. So basically, the goal is to create a facility that balance high speed automation with strict security using VLAN segmentations. So without any further delay, we jump into our the central hub and also the OSI explanation. So as you can see, sir, the middle part is my central communication hub, which also I will known which also as known as my IT department. So let's simulate it. Okay. So as you can see, sir, first we will first from the server. Then it will send it to switch one. From switch one, router will receive, and then from router it will send it back to the switch one, and from the switch one it will send it to each access point according to the needs. Okay, sir. I will explain about the layers. Okay, sir. Alright. So I will show you from this part where these servers where we will have mainly four layers at my project. So the first layer which is known as the physical layer. Basically the physical layer is the part where we use the copper straight through the fiber cables connecting to the different zones to the central rack. As you can see, sir, each switch and routers are connected with our copper straight through wire. And then for the layer 2 is the data link layer. So this data link layer basically will explain how basically it shows how switch 1 uses the VLAN tagging to keep it will make sure to keep the traffic from the lobby VLAN 10 and separate from the admin room. Okay, sir. So as you can see from here, the second layer is basically it shows that the frame destination MAC address matches the receiving port MSC address, and also the device de yeah, decapsulates the PDU from the Ethernet frames. For the third layer is the network where we will have where the part inter VLAN routing will happen. So since there are a lot of different room and network, so I configured that the router 0 and the router on stick to allow authorized communication between the admin PC and all the other PCs, and same goes for the IoT servers. So as you can see here, sir, the packet transfer destination IP address is matches the device's IP address and also the broadcast address. For the layer 4 is basically the transport part where the TCP ports happens. So our system we uses port 80 for standard web traffic and also port 8080 for the specific IoT registration traffic. So here you can see it shows that the TCP push plus ACK segment the connection in to 192.1.68.30.5 on the port 1026. So it will process the payload data and also it resembles all the data segment and passes through the upper layers. And for the last one is layer 7 application where the server 0 will provide and will providing the IoT services to the entire factory, which means after all of the what they call um, all of the IoT servers are starting to work, this application part happens where it also stated here the IoT server received a report states that message from the client and processes the messages. Okay, sir, this is for the OSI layer part. Now we will move on for the each room by room explanation. Okay, sir. So as you can see, the yellow color room, as I said previously, for each room I used each VLAN where I have total 70 VLAN. So the each VLAN we have to connect to different fast Ethernet what they call wire mean connection. So for the VLAN 10, which is my lobby, sorry, it's not lobby. Sorry, the VLAN 10 is for the central communication hub, where actually I arranged each room has their own Wi-Fi system to avoid from any virus. Let's say if a particular MPC for admin group is affected by a virus, it's only affect on the particular room's Wi-Fi area. It doesn't travels to others system in throughout the factories. So, by room, for the yellow color room, which is my lobby main entrance. So in the lobby, I have included webcam, door, RFID card, RFID reader, and also PC, for lobby PC. So basically, how the system works, is by we will what they call we will scan the RFID card to the RFID reader, and the door will open. Once the door open, the webcam starts to operate, so that it basically it's maintain the security, in and out security in the lobby and main entrance. So next I will jump to the admin and HR room. For admin and HR room, I included one, two, three PCs, one laptop, one smartphone, and one printer. Basically, it's for the workforces to do work their own work. Basically, in admin room, they will be handling payroll. They will be handling attendance and stuff. So basically, this zone is evaluated privileged to monitor the rest of the factory, where these peoples all they are have the privileges to look through what other departments are doing as well. So now we are moving to clean room production. For the clean room production, I've used VLAN 70. Basically, this clean room is the most sensitive zone where it has their own strict environmental monitoring, which I've included temperature monitor and also humidity monitor. Let's say the temperature monitor is there are a range for the temperature monitor which means between 24 and below. The aircon will automatically turn on, and same goes for the humidity monitor. Let's say the humidity monitor above 80, then the sirens will work. Okay, now we move to the QA laboratory. For the QA laboratory, same only. We have a door, we have temperature monitor, we have air conditioner, and also we have siren. Let's say the temperature monitor is it's not enough, and the air conditioner will start by itself. And let's say there's any unnecessary people who enter the door without any basically some QA laboratory, they have their own unrestricted area. So if some people enter the unrestricted area without their proper SOPs, the siren will be on. And same goes to there are two laptops, and they have their own different access point for QA laboratory. Same goes for others as well. For packaging section, there are webcam and there are two PCs. And for the warehouse, there is one temperature monitor, humidity monitor, and siren. So as you can see, sir, there are each room has their own access point for their own PC setup, for their own IoT sensor setups. So for this, that's the briefly explain on room by room, um, what they call explanation. So next, I would like to say my challenges that I faced throughout this project. So, first problem I had was the VLAN routing problem. Since I have 70 VLANs, it means the difficulties are more higher. So, what happened was initially the PCs couldn't talk to the servers. So, I have to go back to the CLI and ensure the sub interfaces on the router were correctly mapped on the VLAN IDs as well. And also, dealing with this packet transfer browser limitation, it taught me that in a real factory, I have likely to use a dedicated industrial controller like PLC rather than a general purpose web service. And also, I have tried the biggest, hardest conflict throughout my project is packet transfer is HTTP service and also IoT service, where it often will fight for control over the same IP. I had to learn how to troubleshoot the connection reset and also how to properly managing the service parts. So that's all from me, sir. Thank you so much.